Okay, so we are talking about some rules, and we did mention some of them already. So a couple things here. These two are, let me do it like this. These two are related to the how the potential changes. How potential changes. One of them is across resistor, the other one is across like battery or EMF source. Okay, so resistance rule is it's that the potential drops by I times R across a resistor in the direction of the current. So if you're going along the direction of the current, then you will have a drop by I R because comes from the Ohm's law, right? V is equal to IR. And V is the potential, so that's the potential magnitude. So it will be either a drop or an increase depending on the direction. If you go along the direction of the current through the resistor, and then there will be a potential drop across the resistor. And the potential increase if you go opposite direction to the current. Okay, but it is always I times R. That's what the resistance rule is. And I did mention that in the previous chapter when we discussed that Ohm's law. I told you that it was going to be one of the rules that we will have in the circuits, and that was the resistance rule. And the next one is EMF rule, and this is again when we have an EMF source like a battery or a generator. So here the potential increases by EMF, E, from the negative to positive terminal. Okay, so you have that battery, let's do this, battery kind of figure here. So you have this negative on this side and a positive on that side. So the potential increases from negative to positive terminal, right? So you have an increase when you go from left to right, and this is going to be the direction of the EMF as we will assign. So it's always from negative terminal to the positive one, and it does not care about the current direction. Okay, we don't really check the current direction to define the EMF rule. We just know that from the negative to positive terminal, there is an increase in potential by that E, the EMF. Okay. And next two are the main equations that, and more general equations to obtain equations for the circuit. So what I mean by that is you will have some sort of elements in your circuit, and then you will have, let's say, three unknowns. So first thing we will do is we will apply junction rule, which is at the bottom here, and then we'll see how many junction rule we can write, or how many distinct junction rules we can write, and then we'll think about loop rule. And if we have three unknowns, then we will need to have three total equations, and we will get them from these two. And you may have seen it, and I've been trying to mention this. This one is also known as KVL, Kirchhoff's voltage law, and the junction rule is also known as KCL. This is Kirchhoff's current law. So the textbook uses loop rule and junction rule. I will be using also sometimes KVL, especially for loop rule. But I want you to also kind of know that junction rule is the KCL as well. So it is known as voltage law because we do think about the changes in the potential, and we just write them down. And this is the reason. The reason for that is because the energy is conserved, and potential energy is related to the potential V, right? But this is where it comes from. So for the loop rule comes from the energy conservation. And again, we will just write the sum of the changes across each element, and for the potential. Okay, for the junction rule, the charge is conserved, and we did again mention this before. in the previous chapter. So you can see that previous chapter was really the background chapter. Now we are seeing how to put things together in this chapter. And this is the sum of currents. That's why it's called Kirchhoff's current law, and here Kirchhoff's voltage law. And you're just like adding up all the currents entering in the junction, and that's equal to the sum of currents leaving the junction. What comes in goes out, right? Because the charge is conserved, and we know that charge is related to the current, because current is the rate of charge per time, so the flow of charge per time, so they are related to each other.